Hello friends, hello guys. Once again, I want to say welcome. So from what you can see on the board, we just finished considering the addition in binary or base 2 number system. Addition in base 2 or binary number system. So we're proceeding over to subtraction in binary number system or subtraction in base 2. So quickly, we're going to erase this and continue with the subtraction in binary number system. Subtraction in binary number system. Subtraction in binary number system. So I'm going to say subtraction here. Subtraction in binary number system. So is it really different? No, it's not really different. It's not really difficult as well. So we're going to consider example 1 on subtraction in binary number system. And the first question we're going to have here is going to be 1 0 0 1 1. Then you have 1 0 1. Decide you should subtract. So the question says evaluate the following in base 2. The same way some teachers can also teach you how to cram some key values that are to be subtracted. The same way you're also going to be taught how to cram this, which I think is not really necessary. That 0 minus 0 will give you 0, that 1 minus 0 will give you 1, and then you have something like 1 minus 1 gives you 0. To me, it's not really necessary if you are able to grab the concept I'm about to explain. So now the first question says, evaluate the following in base 2. You're subtracting. The subtracting is not as well difficult. If you follow this routine, you're going to see that 1 minus 1 gives you 0. How about if you're dealing with some other number base? Will you also cram them? That is the question. So apply the same strategy. Of course, 1 minus 1, it is 0, even in base 10. So 0 divided by the base will give you, of course, we're working in base 2, will also give you 0. So whichever way, it still gives you 0. So if you still choose to cram, it's quite cool. It goes along almost like in base 10. But when you're dealing with a different number base, like in base 8, it's entirely a different ball game. So now you say 1 minus 0, as in here, 1 minus 0 gives you 1. Even if you apply this approach, 1 minus 0 is equals to 1. It's not up to the base. So with that, we may choose not to divide. You simply come here, write down 1 here. But even if you choose to divide, since it is not up to the base, you're going to have 1, 2. How about dividing by the base? You're still going to have 0 remaining 1. You can see whichever way, 1 minus 0 still gives you 1. So I'm only doing this in case you are dealing with some other higher number base. So now the next one is this. Pay attention right here. You can't take 1 away from 0. You can't take 1 away from 0. So what do? Even in base 10, when you can take one number from the other, you need to borrow. You need to apply the principle of borrowing to resolve the challenge. So the same way you're going to apply the principle of borrowing. But the difference is this. When you borrow in number base, if you are borrowing 1, that one you're borrowing over becomes the base itself. If you're dealing with 2, base 2, if you're dealing with base 2, and you're borrowing 1 from the next line, the one you're borrowing becomes 2. If you are dealing with base 8, the one you're borrowing automatically becomes 8. If you're dealing with base 9 or whatever base you're dealing with, the one you're borrowing becomes that base. Even if base 16, as in hexadecimal, if you're borrowing 1 from the other, as a result of not being able to subtract, the one you're borrowing becomes 16 automatically. So the same way, we are borrowing 1 from here. Remember, place it here first. When we borrow 1 from here, automatically becomes the base. So right, the base is 2 we're working with. You write 2 here. Now we borrow 1 from here again. This one will now turn to 1. These will turn to 1. Since we have to borrow 1 again from it, I bring it here, automatically here becomes 2. Why? Because when you borrow in a number base, the one you're borrowing automatically become the base you're dealing with. And now you're dealing with base 2. The one we are borrowing from here, which was originally 2, became 2 here instead of 1. So now, 1 away from 2, this 0 will be replaced by 2. So 1 away from 2, or 2 minus 1, automatically becomes 1. So 1 divided by the base gives you 0, remainder 1. So you write 1 here. Or, simply put, 2 minus 1 gives you, yes, 2 minus 1 gives you 1, which is the one here. Remember, we initially borrowed 1 from here. It came here, became 2. We borrowed 1 from 2. It was now left with 1. So 0 minus 1, or better still, 1 minus 0. From what you have here, the principle you have here, 1 minus 0 gives you 1. So you write 1 here. We already borrowed this. So we can't do nothing with it anymore. So we simply say, this is the answer. You're right, base 2. As simple as that. It's not difficult. To make you understand better, I'm going to take another example with more digit numbers for you to understand better. So let's take or consider example 2. Let's take example 2. So example 2 is saying you should evaluate the following in base 2. Evaluate the following in base 2. But unfortunately for us, this has a decimal number, but it's still going to be very simple. It says 1111 01.01 minus 101, then 00, pardon, let me take it again. It says minus 11.00 then 01. So what happens if you were asked to subtract these values? What happens? This is going to be 1 and 0. So what happens if you were given such a question? What do you do? What do you do? Let me cross check the values. So what do you do in this case? What do you do when you were given 2? Subtract 11101.10 and 10100.11. So what do you do? We simply do our subtraction. Remember, you can't take 1 away from 0. You borrow 1. Automatically, the one you're borrowing to bring to this line become the base, which is going to be 2. It's going to be 2. So now, 2 minus 1 gives you 1. Even if you apply the system I actually taught you earlier on by saying the one you got is 1 divided by the base, it's going to give you 0 remainder 1. So bring down the 1 here. What is left here? We are left with 0 here. We can't take 1 away from 0 again, so we borrow from here. When we borrow from here, it comes here. The one we're borrowing automatically becomes the 2. Remember, here it's left with 0 here. Because this one had been initially borrowed out. So now 2 minus 1 gives you 1. Even if you say the 1 divided by 2, you still have 0 remainder 1. Remember, place your dot, decimal marker. place your decimal marker. Remember, here is left with, we are left with 0 here. So 0 from 0 gives you 0. How about there? 0 from 0 gives you 0. How about 1 minus 1 gives you 0? How about 1 minus 0 gives you 1? How about 1 minus 1 gives you 0? But it is needless writing the 0 if it comes first. Needless writing if it comes first. It doesn't matter. So you say, this is the answer. That is the answer we got. So that is how to carry out subtraction in number base. That's how to carry out subtraction in number base. Or the principle you need to store in your brain, the fact that in working in any number base, be it base 10, be it base 16, be it base 8, be it base 3, 5, and etc. Remember, except for base 10, when you borrow in base 10, the one you're borrowing becomes 1. But in other bases, the one you are borrowing automatically becomes the base. Are you working in base 2? And you need to borrow 1 from the other. The one you borrowed automatically becomes 2. Are you working in base 3? If you borrow, if at any point in time you choose to borrow, the one you're borrowing becomes 3. If you're working in base 16, the one you're borrowing becomes 16. Thanks. And thank you for being patient to the end of my class. You can endeavor to watch the video over and over and over again for better understanding. Thanks for being part of my class. I really do appreciate. Please kindly comment and like my video. Thank you very much.